Shall I start?
Okay, madam, you can start.
Okay. Good afternoon, students. Today we will start with our fourth lecture on fluid mechanics, and today we will cover the topics of channel hydraulics. Okay. In channel hydraulics, we are going to cover about the open channel flow and about the static energy and its diagram, then about the most economic channel, and about the concept of hydraulic jump in GPF profiles. Okay. So we'll come with the open channel hydraulics. Now, before going for the open channel hydraulics, we must know that what is the open channel. Now we have already understood about the pipe systems or the flow through pipes. So open channel is a channel or a flow in which your liquid flow is in a conduit with a free surface. That is a one surface on which your pressure is equal to the local atmospheric pressure. Okay, or in another word you can say the flow in this channel is not caused by some external head but rather only by gravitational component along with the slope of channel. That is, in this figure you can see in open channel you are having only the three component or three edges which are covered by the water, or it is having the three edges which are having the weighted parameter. Here we have to consider only the three edges for calculating the weighted parameters or the weighted perimeter. Now, how to compare the open channel with the closed conduit? So, for that, the simple classification has been mentioned over here. In open channel, we consider the gravity force only, but when your pipe is there, you can run the pipe network under hydraulic pressure as well as under the gravitational pressure. When you are talking about the cross-sectional area, open channel may have any shape like triangular, rectangular, trapezoidal, parabolic or circular. As you can see in this figure, okay, open channel may have any sort of shape. But when you are considering the pipe flow, they are generally circular or uniform along the length. Then surface roughness. When you are talking about open channel, in open channel, the surface roughness varies with the depth of flow, but in pipe varies with the type of pipe material. Then head, where head is Z plus H. Z is your the depth of water and your H is the depth of channel. Okay, Z is the reference level from the bottom and H is the water level into the channel. And when you are checking for the pipe flow, your Z is your bottom level and H is your depth of channel. Sorry, P is your depth of channel, but here you have to take the P by gamma component, that is the pressure component. P by gamma is nothing but your pressure head, that will be in terms of meter only. Okay, in previous classes we have seen about it. When you are talking for open channel, here your flow area is determined by the geometry of channel plus the level of surface. Okay, but when we are talking for pipe systems, your flow area is fixed and it will be decided by the dimensions of pipe only and the cross sections of the pipe only. In open channel, your velocity is maximum at the distance below the water surface, and the shape of the velocity profile is dependent on the channel roughness. Whereas in pipe flow, the velocity distribution is symmetrical about the whole length of the pipe. The maximum velocity will occur at the center of pipe, and minimum velocity will occur at the edges of the pipe or at the wall surface. In open channel again, your cross section may be of any shape from circular to irregular forms also. Irregular forms will occur in case of natural streams which may change along the flow direction. But when we are talking for the pipe network, the cross section of a pipe is usually circular, or you may also call it as a is of a uniform section. Here in open channel, see also your depth of flow, your discharge, your slopes value may vary along the free surface because they are interdependent. If your depth will change, your discharge will change, your slope will change, and everything will change. But in pipe network, there is no such dependency because pipe networks are generally uniform in dimensions. Okay, so on the basis of this, open channels are classified into the two types of flow, that is the steady flow and unsteady flow. Steady flows are again classified as uniform flow and ununiform flow, and unsteady flows are classified as gradually varied flow and rapidly varied flow. Non-uniforms are again classified as gradually varied flow and rapidly varied flow. Okay. Now the uniform flow, or called it as a normal flow, is the simplest form which is having a depth constant at every section along the length of the channel. And when your depth will change along the length of the channel, the flow will be classified as the unsteady flow or non-uniform flow or varied flow. Again in varied flow, the flow has two types, that is the RVF and the GVF profile. RVF is your rapidly varying flow profile and GVF are your gradually varying flow profile. When your depth of the channel changes abruptly over a small length of the channel section, then it will be called as a rapidly varied flow. And when your depth of the section changes gradually over the length of the channel, then it will be termed as a gradually varied flow. Here see, it will be clear from this picture that as GVF and RVF profiles, here you can see when your length of the channel is quite longer and the change in the depth of the section is lesser, then it will be termed as a gradually varied flow. But when the change is abrupt over a small length of the channel, then it will be the rapidly varying flow. Then see here, there is a depth is constant, also the channel length is constant, then it will be termed as a uniform flow. Again your depth is varying, it is termed as gradually varying flow, and then depth is changing abruptly. Is it? So it is termed as a rapidly varying. Now while designing the gradually varied flow channel, there are few assumptions which we have made. The first assumption is that your channel is prismatic and flow is steady. Then your second assumption is hello. Okay, sorry, I was disconnected. Your channel is prismatic and flow is steady. Then second is your bed slope is relatively small. Then velocity distribution in the vertical section is uniform, and the kinetic energy correction factor is close to unity. Then the flow is streamlined. Streamlined flow is nothing but your laminar flow, and pressure distribution is hydrostatic. Hydrostatic in the sense it is uniform throughout the channel. Then the channel roughness is constant along the length and does not depend on the depth of the flow. So these are the five assumptions which we have to make while deriving the equations for the gradually varied flow. Now what is prismatic channel? Prismatic is nothing but a channel which is having constant cross-sectional area, size, as well as bottom in terms of the channel conditions. Okay, all natural channels generally having varying cross section. Is it? but the man-made sections or the artificial sections may have the prismatic type of conditions. But when we are talking for the natural conditions, then channel cannot be said to be a prismatic one. Okay, so there are two types of channels. Natural channels are there, artificial channels are there, then there are open channels, covered channels and prismatic channels. Natural channels is one which is having the irregular section of having shapes developing in natural ways. An artificial channel is one which is built artificially for carrying water for various purposes like canals and open channels which are not covered at the top or which are only having the three edges with any shape like rectangular, trapezoidal, circular or triangular. Then there are covered channels. Covered channels are covered at the top, which are partially filled like your closed conduits, or you may also call it as the pipe system, either fully uh, filled or the partially filled. Then prismatic channels. Prismatic channels are the channels which may be open channel, which may be covered channel, which may be artificial channel, which may be natural channel. But for prismatic channel, your condition should be that it should have a constant bed slope as well as cross section along its length. Okay, so out of which for right, we have to learn about the open channel. So in open channels, we have basically two types of flow, steady and unsteady flow and uniform and non-uniform flow. Steady and unsteady flows are the flow in which your flow parameters will not change with respect to time along the depth or along the length of the section. And uniform and non-uniform sections have the sections which will have the constant velocity along its length. Okay, then your flow will be classified on the basis of third classification, that is on the basis of the Reynolds number, that is laminar flow and turbulent flow. The steady flow and uniform flow definitions are same as we have learned for the pipe system or the pipe flow through pipes. For Reynolds number, here the numbers have been changed. The formula will be same. For open for pipe system, you have taken the equation as rho Vd by mu. Here also your equation is same, that is rho Vd by mu, or you can say Vd by mu. Okay, that is mu by density is nothing but your mu, that is the kinematic viscosity. So V in D, for D here we have to take the R. Okay, that is the RH or the overall depth of the channel. But in flow through pipes, your Reynolds number should be less than 2000 for the laminar flow. Here the value is less than or equals to 500 when it will be standard, or when we have it should be defined as the laminar flow. When your Reynolds number is coming out to be greater than 1000 or equals to 1000, then your flow is set to be turbulent flow. And when it is in between 500 to 1000, then your flow is set to be transitional flow in terms of flow in open channel. Okay, and you can calculate the Reynolds number by using this equation, that is V by R divided by mu, where mu is nothing but your mu by density. Then another classification can be done on the basis of Proud's number. Now Proud's number will be calculated as FR is equals to V divided by square root of GH. In terms of flow through pipes, the equation is modified as V divided by square root of GD. Here you have to take square root of G into H. Okay, H is nothing but your depth of water or depth of flow. So on the basis of Proud's number, the flow in open channel can be classified as subcritical, critical or supercritical flow. And Proud's number is your ratio of inertial force to gravitational force. If your Proud's number is less than 1, then flow is said to be subcritical flow. If your Proud's number is equals to 1, then flow is said to be critical flow. And if your Proud's number is greater than 1, then your flow is said to be supercritical flow. Now, what is the advantage of calculating the flow type If your flow is said to be subcritical flow, then there may no chances of the hydraulic jump. If your flow is said to be critical flow, then your energy will be maximum at that section, or you can say that energy is the specific energy where your flow is critical flow. And when your flow is supercritical flow, then there will be gradually varying flow, or you can say normal flow or steady flow will occur in that section. Now, before moving further, these are few equations or few formulas which you can use for calculating the various parameters like area, weighted perimeter, hydraulic radius, top width, and the hydraulic depth for the common sections without using the concept of most economic channel section, as we will see in few minutes or couple of slides after the couple of slides. Okay, if your section is rectangular, then your area will be B into H. If it is trapezoidal, then your area will be calculated as B plus slope into depth of water into depth of water. If it is rectangular one, then your area will be slope into h square, or in general you take it as half depth into width. Okay, if it is a circular, then it is 1 by 8 theta minus sine theta into d square, and if it is parabolic, then you can take it as 2 by 3 d by h. Here you can also use 1 by 4 d square, but if when for circular cross section, when your water is running full through the circular pipe network. If it is running halfway or somewhere here, then you have to use this formula. Okay, and you can calculate weighted perimeter by means of these formulas: hydraulic radius, top width, and hydraulic depth. So all the formulas are given. So if supposed to be you are not having knowledge of most economic channel section, you can also use these formulas to calculate the channel hydraulic unknown quantities or the flow rate quantities out of the given equations. Now moving further for the characteristics of uniform flow out for the open channel hydraulic. Here consider an open channel which is having a datum and a water is flowing at the distance of y1, and a channel bottom is at the distance of z1 from the reference line or from the datum. Okay, your datum is having a depth of z1 from the datum. Your channel datum is having a depth of z1 from the reference datum, and your water surface or the water level is at the difference of y from the channel bottom. Then your V1 square by 2G is the energy line for the given water surface. Okay, here we have assumed that S is the slope of energy line, SW is the slope of water line, and S0 is the slope of channel bed. Now here what will happen when we have to calculate the energies at this section for this water line, then we know the equation for energy by means of Bernoulli's equation, that Z plus y plus v1 square by 2g must be equals to z plus y2 plus v2 square by 2g plus HL, that is the head losses. Here see, summation of all the three energies or all the three heads is going to give you the total energy at this section. Okay, so for the left hand side my energy will be z1 plus y1 plus v1 square by 2g, and for the right hand side my energy will be z2 plus y2 plus v2 square by 2g plus HL, that is the head losses. So these two energies must be equal for getting the for satisfying the energy equation in that section. Okay, but mathematically when you are talking for the specific energy is nothing but E is equals to y plus v square by 2g. When you are taking that reference of this section is nothing but your bed channel. Okay, if we are eliminating this reference line, that is this head one, we are assuming that our reference or bottom section is available at the y1 section only, then your energy equation will be reduced to E is equals to y plus v square by 2g. Is it? Now your discharge per unit width is termed as your small q. Okay, so here when your E is equals to y plus v square by 2g, v square can be converted to capital Q square by a square, and capital Q square can be converted into a into v. So a into v divided by v, area will be written as v into y divided by b. So b will get cancelled. So your small key, that is the discharge per unit width, will be written as v by y, that is velocity into depth of the flow. Okay, so replace that into the equation. So you will get final energy equation as y plus q square divided by 2g y square. Okay, so this is the final equation or the specific energy equation by means of which you can calculate specific energy at any section. That is either E is equals to y plus b square by 2g, or it will change the form of this equation. This may be converted to E is equals to y plus q square by 2g y square. Okay. Then we'll move for the specific energy and the critical energy. Now, specific energy, this diagram is nothing but your specific energy diagram. Now here, from this equation, on the x-axis we have plotted the specific energies, and on the y-axis we have plotted the depth of the channels. Okay, so as we know, the equation of specific energy is y plus q square by 2g y square. Okay, there small q is the discharge per unit width. Here, if you have plot this equation for only potential energy, that is E is equals to y. Your y is nothing but the potential energy, and your q square by 2g by y square is your kinetic energy. So specific energy is the summation of potential energy plus kinetic energy. So if we are assumed that there is no kinetic energy, that your water is at rest position, it is not moving anywhere, so your E must be equals to y. So you will get a straight line equation or a static head. That is, your energy will be directly equals to the depth of the channel. Okay, that is E is equals to y, and that straight line curve will be equals to the, will be inclined at the 45 degrees. Then when you will plot E is equals to y plus q square by 2g into y square, that is E is equals to, or you will plot E is equals to kinetic energy, that is E is equals to q square by 2g into y square. So you will get a bigger size parabola from y to E in between y and E axis. And when you will plot E is equals to y plus q square by 2g, then you will get a curve which is shown into the blue line. Now, in case of open channel, specific energy is the energy, length or head relative to your channel bottom. It is also, you can also call this as a fundamental relationship used in the standard step method to calculate how the depth of flow changes over to reach the energy gain or loss due to the slope of the channel. Okay, so this figure or this diagram will give you or will show you the pattern that how your energy is actually varying on the basis of your depth of channel. So if supposed to be your energy is maximum or your energy is minimum, so at the point of minimum energy you will get the maximum depth at the critical section, or you can also call it as the critical depth. That is, yc will be related to the E minimum. E minimum will be related to the yc, and all the depth other than the critical depth will be termed as your conjugate depth or the alternative depth. Okay, here see it is written as it is clear from energy depth diagram, that is EY diagram, drawn for constant discharge for any given value of energy, there would be two possible depths, say y1 and y2. Is it? If suppose to I will take any energy, here I have taken a point, I will get two energies. If I will plot a straight line for any given energy, so I will get two depths. One at bottom one and at one will be above the yc. So these two depths will be termed as your alternative depth. How for point C, that is for the critical point corresponding to minimum specific energy, there would be only one possible depth, that is the yc, and yc is termed as your critical depth. The critical depth may be defined as depth corresponding to minimum specific energy discharge remaining constant. Okay, so only for critical depth there will be a energy which will be the minimum energy. Other than for all the energies, there will be two depths which are known as the alternative depth for that particular energy. So for calculating the different depth, we are having the Proud's number. If your Proud's number is greater than 1, then it will be supercritical flow, and if it is less than 1, then it will be subcritical flow. So once we know about the critical flow, subcritical flow, and supercritical flow, we can relate these flows by means of this specific energy. Okay? If Yc is equals to 1, that will be your critical flow. If it will comes out to be greater than 1, then it will be your supercritical, and if it is less than 1, then it will be a subcritical flow. Subcritical flow is also called as a tranquil flow or the slow flow, and supercritical flow is also termed as shooting flow, rapid flow, or the fast flow. As name itself is suggesting, its velocity is higher. Because of this, it is rapid, fast, and shooting one. Now, critical depth for rectangular channel can be calculated by means of this formula, that is yc is equals to q square by g to the power 1 by 3, where small q is nothing but your discharge per unit width, that is capital Q by d, and E minimum or critical energy. Now energy is calculated as y plus v square by 2g, is it? So here E is equals to y plus yc by 2, that is half of energy. So your E minimum will be your 3 by 2 critical depth or 1 by 2 critical depth. Okay, and when it is a non-rectangular channel, then we have to use this formula, that is A cube divided by T is equals to Q square divided by G, when your Y is equals to YC and your capital T is the top width of channel. Now, for solving the open channel, we have two main equations, that is the Chase's equation and the Manning's equation. By applying the force balance along the direction of flow in an open channel having uniform flow, the following equation can be derived. Both equations are widely used for designing the open channel. Okay, Chase's equation is V is equals to C square root of Rs. When we will replace this by continuity equation, that is Q is equals to area into velocity. So velocity will be replaced by V is equals to C square root of Rs. So we'll get a final discharge equation as Q is equals to CA square root of R into S0. Okay, where C is the Chase's constant, S is the slope, then A is the cross-sectional area, R is the hydraulic radius, V is the mean velocity. Then there is one more equation, that is the Manning's equation. Manning's equation is V is equals to 1 by n R to the power 2 by 3 x to the power 1 by 2. Again, the modified equation for the Manning's equation will be Q is equals to 1 by n r a into r to the power 2 by 3 s to the power 1 by 2. Okay, again here v is velocity, n is the Manning's roughness constant, then r is the hydraulic radius, s is the frictional slope, and A is the cross-sectional area. Now, there are few equations or the derivations which we should know about the open channel hydraulics. Now, first equation is for the energy equation for the GVF profile, that is for the gradually varied flow. Okay. Now, before going for this, we should know about the few notations. That is, Y is the depth of channel or H is the depth of channel. A is the area. Capital T is the weighted perimeter, and capital T is the top width. Okay. Hydraulic radius will be calculated as area divided by weighted perimeter. Okay, not area divided by perimeter, but weighted perimeter. That is RH. And DH is nothing but your area divided by top width, that is your hydraulic depth. Okay, so hydraulic depth and hydraulic radius. These are two different terms in open channel. For hydraulic radius, we have to divide area by weighted perimeter, and for hydraulic depth, you have to divide area by top width. Now here see, when we have seen the energy equation or the energy profile into this figure, just yes, into this figure here we had taken SF or S0 as the slope of channel line, then SW is the slope of water, and S is the slope of energy line. Is it? So from this equation we have derived and formula, that is Z is equals to H plus Y plus B square by 2G must be equals to Z plus Y plus 2 square divided by 2Y square into G. Here you have taken another equation, that is Y1 plus B square by 2G must be equals to Y2 plus B square by 2G at two different sections plus HL. Okay, so when we will simplify this equation, you will get a final equation, that is del L is equals to E1 minus E2 divided by S0 minus SW. That is, this is termed as your energy equation in terms of slopes over the length of water cycle. This is also termed as approximate analysis of gradually varied non-uniform flow. It will be calculated by considering the length of string consisting of number of successive reaches, in each of which uniform occur. Greater accuracy results from smaller depth variation in each step. Okay, so for calculating the energies with respect to your given slopes, we have to divide this section into the multiple lengths, and then you will calculate, so we'll get the accurate result. So we have the Manning's equation and Changes equation. By using these two equations, you can calculate the average conditions for the given slopes. Now, if supposed to be you have to find out the slope of channel, that is dy by dx, then you can use this formula, that is S0 minus S divided by 1 minus f square. That is slope of channel bed minus slope of water line minus slope of energy line is it divided by 1 minus crowd number, that is f square. Okay, where S is your slope of energy line and S0 is your slope of channel bottom or the bottom. Dy by dx is nothing but your slope of channel. Now here few conditions are given. If your Froude's number is equals to 1, then your dy by dx is infinity. That is, if your Froude's number is occur as 1, your section will be critical section and your slope will be infinity. If it is greater than 1, then denominator is negative. And if your uh, f or Trout number is lesser than 1, then your denominator is positive. So denominator is positive, then it will be going to give you a positive answer. Now this is for the channel or a normal channel. But when your section is a rectangular in nature with a wide rectangular base, a channel is wide, then what will happen? Your hydraulic mean radius or the hydraulic radius will be equal to the depth of the section. So your formula of Manning's constant, that is V is equals to 1 by n r to the power 2 by 3 s to the power 1 by 2, will be changed by y to the power 2 by 3. When you will solve this and you will replace all the values in terms of small q's, so you will get this final equation, that is s by s0 is equals to y0 by y to the power 10 by 3. Where s is slope of energy line and S0 is slope of channel or slope of channel bottom. Okay, this is the case when your section is given as a wide rectangular channel section, and if your section is given as rectangular channel only, then it will be d by dx equals to S0 minus S divided by 1 minus F square. Okay, so on the basis of these equations, I have mentioned 2-3 examples. We will quickly go through it. So if your water, your problem is given as water is flowing in a 2 meter wide rectangular big channel having Manning's constant as 0.016 at depth of 120 centimeters. The bed slope is 0.0012. Estimate the flow rate using the Manning's equation. Okay, a simple problem is given. You have to find out the flow rate, that is the discharge. Discharge by Manning's equation can be calculated as 1 by n a to the power 2 by 3 s to the power, sorry, a into r to the power 2 by 3 s to the power 1 by 2. Okay. Now the hydraulic radius will be calculated as area divided by weighted perimeter. Area is b by y and weighted perimeter is b plus 2y. So width is given as 2 meter and depth is given as 1.2 meter. So it will be 0.545. N is given as 0.016. So replace the values, you will get the discharge value as 3.47 meter cube per second. Okay. Here again a wide rectangular clean earth channel has a flow rate of q 50 meter cube 50 feet square per second into feet. What is the critical depth and what type of flow if y is equal to 3 feet? Okay. Now see here a wide rectangular section is given and critical depth you have to find out. So critical depth is nothing but q square by g to the power 1 by 3. Okay. So q is given as, small q is already given. If it is not given, then you have to find out it by dividing the width of the channel. It will be given to you. That is discharge per unit weight q divided by d will be a small q. Here in this case it is directly given. So 50 square divided by g, that is, it is given in feet. So it is 32.2. Okay. In meter square, in feet square per second. We have to convert it. Then you will get the final answer as 4.27 feet. And if the actual depth is 3 feet, which is less than the critical one, okay, your actual YC is 4.27. And if it is less than uh, 4.27, then your flow is said to be supercritical flow. Okay. You have to ask that if it is 3 meters, it's supposed to be, you have to ask that y is equal to 6 meters, then your answer should be it is subcritical flow. Then again here in this problem, a rectangular channel is given with 15 feet wide, carries a flow of 350 CFC. Find a critical depth. Critical depth will be again calculated as yc is equals to q square by g, and critical velocity will be g into yc to the power 1 by 2. That is square root of gh. Okay. As here we have to take y is equals to yc, then your slope will be your SC, that is S0 is equals to SC. Channel bottom slope will be equals to the energy line slope. So here Q, or that is discharge, will be equals to 1 by n r to the power 2 by 3 and s to the power 1 by 2. Okay, you can use this equation and n is directly given to you. So just put the values and get the answer. This is homework for you. Just put out all the values and you will get the answer for the critical depth, that is YC, critical velocity is VC. Okay, and you have to find out the slope, that is S0. So you can calculate R, you can calculate A, you can calculate discharge also. So put all the values, you will get the value of S0. Now next topic is your most economic channel sections. Now this is quite important. What are the most economic channel sections? Now see here, we have seen few equations. Now these equations can be used if supposed to be you are not given with the most economic channel section conditions. Okay, it means you can solve this by using the normal formulas or the universal formulas. But when we have to consider the most economic channel section, what is most economic channel section? What does it mean? Most economic channel sections are the sections which will give you the maximum discharge. Okay. So what are the most economic channel sections? These are the sections which will give you the maximum discharge for a given cross-sectional area as well as for the given cross-sectional bed shape as well as for the given cross-sectional slope. Okay. It will have the minimum weighted perimeter and it will involve the lesser evaluation or excavation for the design amount of discharge. So basically, most economic sections are the sections which are having the maximum discharge for the given minimum weighted perimeter. Okay, you have to maximize the discharge with the given weighted perimeter. So what should be the depth, what should be the width, what should be the slope? This will be the combination by means of which you will get the maximum discharge for the minimum weighted perimeter. Okay. So when we will write that equation for Manning's equation, that is Q is directly proportional to 1 by n r to the power 2 by 3 s to the power 1 by 2. Okay, so it is directly proportional. Here your hydraulic radius is directly proportional, so discharge is directly proportional to area divided by perimeter, and it is inversely proportional to the perimeter. So what does it mean? You should have, or we want maximum discharge for the minimum perimeter, or you should have perimeter for which we should it will give you the maximum amount of discharge. Okay, therefore the most economic section, also called as the best section or efficient section, is one which gives the maximum discharge for a given area of cross section or for the given perimeter. Okay, so first most economic channel section we consider is the rectangular section. For rectangular section, it's supposed to be I had taken a rectangular section with depth h and width b. So while applying the most economic channel section concept, we know that it should have the minimum perimeter. Okay, minimum perimeter in terms of depth. So your dp by dh for given section should be equals to 0. This is the most important condition, as we have learned into the differential equation. To minimize the thing, it should be equated to the 0. So this is the condition by means of which you can calculate the most economic channel section condition, that your perimeter should be equals to 0 in terms of depth. Okay, so put all the values, that is dp by dh, that is perimeter should be differentiated with respect to depth of the channel. So perimeter is nothing but your b plus twice of h. Okay, and b is nothing but your area divided by h. Equated to 0, you will get a condition that b is equals to 2h, or depth of section is equals to b by 2. That is, your width of the channel must be equals to 2 times the depth of the section, or your depth of the section must be equals to half of the width. This is the condition for the most economic rectangular section, when your width is twice the depth of the section. Okay, it's supposed to be given with the that you have to consider the most economic channel section, then you should directly use width is equals to 2h or h is equals to b by 2. Okay, in that case you don't no need to consider width is equals to given value, or h is equals to given value. It is supposed to be most economic channel section, most efficient section. This word has been given, and you can directly take b is equals to 2 by h and h is equals to v by 2. The second one is your most economic trapezoidal section. Here in trapezoidal section, again you have to equate the area, or you have to find out area, that is bh plus h square, where s is nothing but the side slope, which will be your h into h square plus 1. And perimeter is again written over here, so you have to equate this perimeter equation with respect to 0. Then you will get the most economic trapezoidal section condition. This one is the most economic trapezoidal section condition, that is b plus twice h is equals to twice h square root of s square plus 1, where s is nothing but your slope of channel, or the horizontal component of the slope of the send depth, or the inclined depth. Hence, for most economical channel section, top width is twice the length of the one sloping side, or half of the top width is equals to length of the one sloping side. Then there are open channel water surfaces for gradually varied flow. There are 5 types of water surface or water surface profiles for gradually varied flow. These are mild slope, critical slope, horizontal slope, steep slope, and adverse slope. Okay. Then your natural depth, or YN. Now see here, 3 types of depths are there. One is your Y, that is your channel depth. N is your YN. YN is your natural depth, and YC is your critical depth. Okay. So if your critical depth YC is lesser than YN, then your slope is termed as mild slope. If your YN or the YC both are equal, that is YN is equals to YC, then your slope is termed as critical slope. When your YN is infinity and YC is limited, or it is countable, then it will be a horizontal slope. When your YN is not predictable, then it will be your adverse slope. And when your slope is reverse in direction, that is the opposite slope, and your YC critical depth is higher than your YN, then your slope will become as a steep slope. Okay. Then there is another concept, that is the hydraulic jump. So most economic channel sections are basically of rectangular, trapezoidal, triangular, and circular shape. Okay. So on the basis of these four most economic channel section, you have to solve the problem. Out of this, rectangular section and trapezoidal sections are most probably asked into your examination, and are most commonly practically built or constructed type of structures. Okay. For rectangular section, your condition is width should be equal to twice of depth, and for trapezoidal section, this condition should be satisfied, that is b plus twice s h is equals to twice h into square root of s square plus 1. Then your next topic is hydraulic jump. This is again one of the important concepts when we are talking for the open channel. Now, what is hydraulic jump? Hydraulic jump is a jump where depth of the flow of water changes from supercritical to subcritical state. And when the slope of open channel decreases for steep to mild, the depth of flow of water increases toward the critical depth, and flow instantly occur at the same point. Now what does it mean? Just observe this figure here. What is happening? Your water is suddenly obstructed by the object or a obstruction. Because of this, what is happening, there is suddenly change into the depth of water, where before it is actually moving out of the higher amount of depth, and now it is moving with the lower amount of depth over the weir or notches or any obstructions. Because of this, what is happening, the velocity is suddenly increasing, and then it is suddenly again increasing. So there is jump will occur at the y1 and the y2 section, between the y1 and y2 section, because of this obstruction. Okay. So what is hydraulic jump? or it is also called as the standing wave. When the depth of flow of water changes from supercritical to subcritical state, here at the Y1, the depth is lesser, your flow is supercritical. That is your Proud's number is greater than 1. But when, because of this, there is sudden change in the energy of the water form or the water depth, and it is changing its form to subcritical state. That is, Proud's number is lesser than 1. So because of this, what is happening? The flow is changing its form, and because of this, the hydraulic jump is happening. Now, other than the hydraulic uh, depth or the critical depth, two depths are termed as your conjugate depth or the alternate depth. Now, what is the basic use of hydraulic jump? Hydraulic jump is necessary to reduce the energy of water while the discharge downfalls in a spillway. What is happening on the upstream from upstream side to downstream side? There is huge amount of energy which cannot be passed. So because of this, what will happen if there is either artificial jump or a natural jump? Because of this, there will be reduction into the energy, and it becomes necessary to reduce its energy and maintain stable velocity. That phenomena is called as the energy dissipation in hydraulic structure. Whatever energy hydraulic jump will occur and whatever amount of energy is being dissipated by means of hydraulic jump, that energy will be used into the converted form or into the steam form by the other usable things. Now, based on the Proud's number or the type of jump that happened, hydraulic jumps are again classified. The first one is your undular jump or the undular hydraulic jump. When your Proud's number is in between 1 to 1.7. Undular type of hydraulic jump is irregular type of hydraulic jump that probably form, and there are certain turbulence in the water particle. Figure number A you can observe. It is the certain turbulent type of water particles will happen, and its Reynolds number is quite lesser compared to the other type of jump. Second one jump is the weak jump. When our hydraulic number is between 1.57 to 2.5, then the jump is called as weak jump, and water is velocity in water is very less, and the water particle cannot be stable and flow in the various directions or the various ways. Third one is your oscillatory jump. Its Proud's number is in between 2.5 to 4.5. Oscillatory jumps form when an oscillatory jet enters into the supercritical state. And here your flow is dependent on heavy flow of air in the one direction. That is, your water will flow into the one direction only, but with the supercritical state. Then next one is your Proud's number having 4.5 to 9 range, and it is termed as a steady hydraulic jump. When this type of jump occur when your bed surface is quite rough and particles start to tend in one direction with heavy velocity and turbulence. Frictional losses are more in this type of jump. Okay, because the pipe surface is rough surface. The next type of jump is a strong jump, which is having the Proud's number greater than or equals to 9, and this occurs. Strong jump is the perfect type of jump when it will form when frictional losses are more and air pressure division is equal and velocity is very high, that losses takes place. The water changes its state from supercritical to subcritical in very short length and when compared to all other type of hydraulic jump. So this jump is highly preferred in the dam structure. See, uh, hydraulic jumps can be artificial in nature. What are the advantages of it? Hydraulic jump is used to dissipate the energy, either to dissipate the energy or to destroy the energy of water where it is needed. Otherwise, it may cause damage to the hydraulic structure. Okay, if there is a sudden turbulence into the water, what will happen? There will be destruction or there will be damage to the construction component like dam, bridges, barrages, notches here, whatever it may be constructed over here. So if the energy into the water is reached to its ultimate point, then there may be collapse, there may be failure into that water body. So just to avoid that point, we have to make the artificial jumps so that energy can be dissipated or that energy can be destroyed. It may also use as a discharge measuring device. Again, next uses it will be used for mixing of certain chemicals like in case of water treatment plant. Okay, in terms of water treatment plant, uh, there can be hydraulic jump just to mix the chemicals. Okay, then other than the critical depth, two other depths are there that these are the conjugate depth. So to calculate the conjugate depth, just take one section before the depth and another section after the jump. So y1 is the depth before jump and y2 is the depth after the jump. S0 is the slope of channel bed. F1 and F2 are the Proud's number before and after the jump at section 1 and 2 respectively. Okay, so we have to apply the momentum equation before and after the jump. So it will be density into discharge V2 minus V1. Okay, two assumptions have been made, that is the slope S0 is equals to 0, that is channel is having a horizontal length. Then if the length is very small, frictional resistance may be neglected, that is the frictional losses have been neglected totally, F is equals to 0. Then we have to apply the momentum equation before and after the jump, and the depth of jump will be taken as y2 minus 5n. Then we have to solve this and you will get a final equation that in terms of y2 and y1, that is y2 is equals to y1 by 2 in bracket minus 1 plus square root of 1 plus 8 fr1 square, or this may be modified as y1 is equals to y2 by 2 minus 1 plus square root of 1 plus 8 fr2 square. So these two equations are called as the conjugate depth equation. If one equation or the one depth is known to you, by means of this depth, by using the Proud's number, you can calculate the other respective depths. Okay, then these are the equations we have seen, that H or the energy at any section is equals to ZB plus Y plus V square by 2G. And if that energy is specific energy, then your channel bottom is nothing but your reference bottom. Okay, so we can neglect the channel bottom depth, that is the ZB, and specific energy will be your E is equals to Y plus V square by 2G. Then here in case of specific energy, your total depth is equals to ZB plus T. Then your ZH by dx is equals to Z dz by dx plus dt by dx. Then your channel slope can be calculated as d by dx is equals to S0 minus Sf, and dy by dx is equals to S0 minus Sf divided by 1 minus Fr square. Then here I have taken few examples on the basis of specific energies. Okay, so we'll take quickly one or two, and rest will be homework or the assignment for you. Okay, a rectangular channel is given with width of 2.5 meters and has a specific energy of 1.5 when carrying a discharge of 6.4 meters per second. Calculate the alternate depth and corresponding Proud's number. Okay, so for specific energy we can use this equation, E is equals to y plus v square by 2g, and v square by 2g can be written as capital Q square by b square. Put all the values. You are not given with the depth of the water section, then you have to use one another equation, that is the Proud's number equation, that is F is equals to V divided by square root of GD. Here it is given as the critical section, so you can use, and it is a rectangular section, so you can use D is equals to area divided by top width A by T, is it, and area is B by Y, and T is nothing but your width. So bits will get cancelled. So Q divided by By into square root of Gy. So Proud's number will be your 0.828 divided by y to the power 3 by 2. So just equate this equation with the upper one, that is 1.5 is equals to y plus 0.34 divided by y square. So you will get a depth for y that is 1.3 and a Proud's number as 0.56. As it is lesser than 1, then your flow is subcritical. Then your flow is coming out as a subcritical flow. And second depth is coming out as 0.63 and your Proud's number is 1.67, that is the supercritical flow. So at the depth y1 you are getting subcritical flow and at the depth y2 you are getting the supercritical flow. Here see, with only y1 and y2 you can differentiate. Y1 is having a depth of 1.3. It means first it is having a higher depth, then it is having a lower depth. First it is having a subcritical flow and then it is moving to the supercritical flow. Okay. Then into this problem, you are given with the most economic channel section condition. The 50-degree triangular channel has a flow of 16 meters per second. Compute critical depth, critical velocity, and the slope if 0.01 and 0.018 is the Manning's constant. Okay, so here see all the section dimensions are given in terms of y. So P A and P is given. You can calculate the hydraulic radius, that is A by P. Then critical flow condition we have to apply. Then apply the critical velocity condition and then apply the critical slope condition or the equation for the Manning's equation. Put all the values, you will get the SC, BC and YC in terms of meter. In next problem, you have to find out the alternative depths. Okay, alternative depths can be find out by means of specific energy or by means of alternative depth equation if Proud's number can be calculated. Okay, here discharge is given to you, depth is given to you for a rectangular channel and width is given to you. Okay, a rectangular channel is here. What is the specific energy? Specific energy is y1 plus v1 square by 2g. v1 square by 2g will be calculated as 0.1 meter. So you will get E1 as 1.6 meter. And alternative depth is calculated by means of Proud's equation and it is 1.6 meter. And y2 is y1 is 1.6 meter and y2 is 0.41 meter. Okay, here for these two equations specific energy plot is also being calculated for given q as well as q1 up to the values of given depth, that is 1, 2, 3, whatever values you can plot. Okay, on the x-axis they had plotted the energy and on the y-axis they had taken the depth. Okay, in next problem you have to calculate the critical depth. Corresponding energy for the discharge is 5 meter cube per second and the other properties of channel are channel width is 2 meters. It is a triangular channel. Okay, with m, that is slope is given 0.5 and trapezoidal channel is having width as 2 and slope as 1.5. Okay, so you have to find out critical depth and specific energy for all the three sections. So here I have given a solution. This will be homework or assignment for you. Just try it at home. This will be all from my end. So today we have learned about the open channel. First of all, we have covered about the channel hydraulics or the specific energies at the channel with the channel conditions. Then we have seen the most economic channel sections. Also, we have learned about the type of flows, that is gradually varied flow or normal flow. Then we have seen the derivation for the Stages and Manning's equation. Then for the sequent depth or the alternative depth, then we have learned about the equation of hydraulic jump, and we have seen few example on the hydraulic jump as well as the most economic channel section. Okay, this is all over from the mind for today. Thank you.